If your parents are telling you to choose CSE because it's safe and a guaranteed high-paying job, they're about 4 years late. There is one branch that is hiring 85,000 freshers by next year in India, and almost nobody in your WhatsApp parents group is talking about it. There is another branch where the Indian fresher salaries have crossed an average of 16 LPA at the top, and there's an entire layer of niche branches that almost no students are told about because no one's researching them. I'm going to walk you through what core engineering actually looks like in 2026, the new age majors and niche branches that no one talks about, and one big mindset shift that Indian families need to make about specializations. If you're in class 11 or 12 or are a parent who's taking this call, then this is the video. I'm Jayasurya. I run Project Ivy. I studied in top universities in India and abroad. And over the last 8 years, I've worked with 400 plus Indian families in their higher education journey, primarily in engineering admissions, both in India and abroad. So let's get into it. After the advent of AI, there has been a narrative that traditional engineering is over. It's not. Well, what is over is the version of engineering that your parents did in the late 1990s and early 2000s. Let me show you what each core branch actually looks like in 2026. Electrical and ECE. This is the most underrated story of the decade. India has committed to building a semiconductor manufacturing base, and our booming chip design market already needs 85,000 engineers in 2026. Across the broader semiconductor sector, the hiring projections is more than 10 lakh jobs by 2027. VLSI fresher salaries in India are right now in between 4 to 16 lakhs per annum. That's higher than the median IT services package. Most EC students in India don't know how great the jobs in VLSI sector are because their college never told them about it. Your ECE syllabus already covers about 60% of what an entry-level chip design requires. You're not starting from zero, you're starting from 60. Mechanical in 2026 is not about thermodynamics or fluid mechanics in the abstract. It's about EV powertrains, battery thermal management, robotics, and additive manufacturing. The Indian EV sector alone needs about 10 lakh engineers by 2030. If you're studying mechanical engineering at a college that still treats robotics as an elective and not a core paper, your curriculum is outdated. Next, civil engineering. It's actually having a quiet comeback that no one is talking about. Smart cities, climate resilient design, sustainable housing, and the entire infrastructure push. But here's the thing, the civil engineer who knows data analytics, GIS, and BIM softwares is making 2 to 3 times more than what a generalist civil graduate is making. Same degree, but a different toolkit. Next is chemical engineering, which is one of the most polarized branches on this list. If you're going to traditional petrochemicals, the runway is really short. The West Asia crisis is proving it. If you're going into clean energy, hydrogen, EV batteries, semiconductors, or specialty chemicals, the runway just got 20 years longer. Same degree, completely different career. Now let's get into the new age degrees, and I want to be careful here. Not every AI and data science branch at every college is a real degree. Half of them are mere CSE degrees with a new sticker. Let me tell you what new majors are real and what they actually open up. First up is robotics. It's the most exciting branch in India right now and the worst marketed. It sits at the intersection of mechanical, electrical, and CS. The hiring is in industry automation, drones, autonomous vehicles, EV manufacturing, and increasingly in defense. If your child loves building physical things and also write decent code, this is the branch. Next up is biomedical engineering and biotech. Here's a number that should change your mind on biomedical. Indian medical devices market is on track to hit $50 billion by 2030. Siemens Healthineers is putting $200 million in Bengaluru Innovation Hub. Medtronic is spending $350 million in its Hyderabad Engineering Center. And the union budget has allocated nearly 1 lakh crore rupees in its union budget. This is not a hospital maintenance job anymore. The biomedical engineer who knows AI is designing the next generation of diagnostic tools. Next up is computational mathematics and pure sciences. And unfortunately, this is the one no one's talking about. A BTech in mathematics and computing or a BSc pure sciences degree in either maths, physics, or chemistry are one of the most underrated degrees in 2026. The kids who are going into these degrees are going into fields like quantitative finance, top R&D companies, and PhDs at world's top schools. The same mathematically rigorous students who used to once choose CSE are now shifting into pure sciences. Why is this happening? CSE has become a commodity. Anyone can learn to code. What matters is hard optimization. And very few people can do hard problem solving using optimization, probability, statistics at the level that is required right now. Now this is the segment where I honestly lose half of my audience, but stick with me. There are about 4 other engineering branches in India that almost get no coverage online. Some of them are dying and some of them are quietly making a big comeback. Let me walk you through them in 90 seconds. First, Aerospace. It's no longer a closed government club. ISRO is hiring, yes, but so is an entire wave of private companies. Skyroot, Agnikul, Pixel, Bellatrix, plus international organizations like GE Aerospace, Airbus India, Collins, Tata Advanced Systems, etc. The Indian aerospace and defense market is being rebuilt. If your child loves rockets and aircraft, this is no longer a niche field, it is a real career. Next up is material science. Material science is the branch that decides whether an EV battery lasts 5 months or 15 years, whether semiconductor chips work at 3 nanometers or fails, whether a satellite survives its re-entry into the Earth's orbit. Every single one of the trending sectors, EV, chips, defense, aerospace, green energy, all of these run on material science underneath. The graduates almost always go on to do an MSc or PhD abroad. And they're the most aggressively recruited PhDs in the global tech sector right now. Next up is Metallurgy. It is the older cousin of material science in some sense. It is dismissed as boring, but truth is every steel plant, every defense manufacturing unit, every EV maker and every aerospace producer in India needs a metallurgist. The competition is thin because no one picks it. PSU placements through GATE are some of the best paying government jobs in India. And the private sector demand from automotive and the defense sector is rising fast. Next is industrial engineering. It is one of the most underrated branches for the students, especially for those who like mathematics and systems level thinking. It teaches optimization, operations research, and supply chain design. Amazon, Flipkart, Walmart, every logistics company and every manufacturer in India hires industrial engineers at scale. And it's one of the most cleanest pathways to an MBA at top global schools because their career trajectory and skill sets almost overlap completely. Now, this is the part that I want every parent and child watching this video to think about carefully. Indian families expect for their children to log their specialization at age 17. Mechanical, civil, EC, CSE. They expect the children to make that choice without even doing an internship or a project ever in their career. Compare that to how doctors are trained. An MBBS is broad. You study anatomy, physiology, surgery, pediatrics, everything. And then the PG, after studying 5 years of real medicine, you choose cardiology, radiology, orthopedics. The specialization comes after the breadth, not before. The best engineering students who are pursuing world-class careers are now structured exactly like this. Their undergraduate degree is broad. A mathematics and computer degree, an engineering sciences, a BSc mathematics, or a mechanical engineering degree at a college where they can also do a minor in AI or finance. And then they can specialize at their master's level when they actually know what they want. This doesn't mean branch does not matter at 17, it does. But the goal at 17 should be picking a branch that opens a lot of doors. Broad undergrad at a strong university and then followed by a specialized master's degree at a global university is a strong pathway to building a good career in engineering. So what does this mean in practice? 3 things. If your child is unsure which branch to pick, go for breadth. Mathematics and computing, engineering sciences, industrial engineering, BSc mathematics or physics, liberal arts with STEM, etc. These keep 5 or 6 career paths open simultaneously. If your child is sure, narrow is fine. If they've done a real project in robotics and they absolutely love it, robotics is a good branch. If they have built circuits and want to do chip design, EC with a VLSI focus works. Specialization at 17 is only smart if it is backed by real evidence. Plan for masters from day one. Pursuing a 2-year masters in India or abroad is no longer an option, but a requirement for high growth careers. So build your undergrad around it. So I hope that was helpful. In case you need any help with planning your UG or PG specializations or careers, do get in touch with me. We've helped hundreds of students make those decisions and got admits into top universities. And we're glad to guide you as well. See you in the next video.